Parabolic bridge application. A parabolic bridge is 45 meter wide. The height of the bridge, 5 meter from the outside edge, is 10 meters. Determine the quadratic function that models the parabolic bridge. Find the maximum height of the bridge. So let's make a sketch of this and then try to solve it, right? So let's say this is the parabolic bridge, and that's a level ground. Now in this case we will assume that when we are trying to make the equation of the bridge, we could have our axis at the origin here or in the center. Either way we can solve it, right? So I'll solve it using my coordinate axis on this side, on one edge of the bridge. And you do the same thing with the vertex or the y-axis right in the center and see what results do you get, right? So here, now if I place my y-axis here and x-axis along the base of the bridge, in that case, the width given to us is 45, so this point will correspond to 45. And we also know that height of the bridge, 5 meter from outside edge, is 10. That means if I move 5 meters from here, then the height is 10. Similarly, I can extend this from the symmetry, 5 meters from here, that means this will be a point at 40. The height will be 10, right? So that is a given situation. Now if we use these as our x-intercepts, then we can write down the equation of this bridge as y equals to a times x minus 45. So that represents the equation of this bridge in factored form. Now since we know one of the points, we can find what a is, and that will give us the equation of the parabola. So we'll substitute this. X is 5 and y is 10. So we get 10 equals to a times 5 minus 45. Now 5 minus 45 is 40 times 5 equals to times a equals to 10. So we can now solve it. So 10 equals to a times, let's write 5 times 40 first, right? And then from here a is equals to, well, this is minus 40. So a will be equals to 10 over 5 times 4 is 20, so minus 200, right? So that is what you get value of a, or which can be simplified and written as minus 1 over 20. So minus 1 over 20 is the value of a for us in this equation. So that gives us the equation of the parabola. And now let's write down our equation, which is the part a. Determine the quadratic function that models the parabolic bridge. So the quadratic function will be y equals to a is minus 1 over 20 x times x minus 45. So this is the quadratic function which models the given situation. Now part B is find the maximum height of the bridge. Now the maximum height of the bridge will be right in the center when x equals to 20, right? So we can substitute 20 here and find our equation. So we get y equals to minus 1 over 20 times x is 20, so x is 20, and we get not 20 but half of 45, sorry, 22.5. So it will be 45 divided by 2, right? Half of 45, so midway in between. So maximum will be at 0 plus 45 divided by 2. That is the axis of symmetry, correct? Which is 22.5. So it is 22.5 minus 45. I should write here times 22.5, okay? Times 5 minus 45. So that gives us the maximum for the bridge. So we can calculate this, which gives us 22.5 minus 45 will be minus 22.5, and this minus and that will become positive 22.5. So we get 22.5 times 22.5 divided by 20 as the maximum height of the bridge. So that gives us, so we can write down here as 22.5 square divided by 20 which is equals to 25.3125, which is 25.3125. So we can round it to approximately 25.3 meters. So the height of this bridge is going to be 25.3 meters. So that is how we can calculate the answer for this particular question. Now, as an exercise, what you should do is you should plot your y-axis right in the center. So then these will be 22.5 apart, right? Minus 22.5 and plus 22.5, and find the equation of the parabola, right? As an exercise. Well, so for this one, we do get our answer, and that is the equation of the bridge is here, that is part A, and second, the maximum height is 25.3 meters. Thank you.